Hi guys, and welcome to Science with Mr. G. Today we're going to be doing our light diffusion lab, and we're going to be answering the question, how does the smoothness of a material affect the reflection of light? Through this lab, we're going to be looking at the differences between the independent variable, the dependent variable, and the control variable. We'll also be creating a diagram of our observations during the lab. Okay, for this lab, what we're going to need are 2 sheets of aluminum foil, a flashlight, and also a light meter. If you don't have a light meter, you can find one on Amazon for about 20 bucks. I've attached this lab sheet in the description below, which will help you document your observations during the lab. So for our materials, we have a flashlight. We have 1 sheet of aluminum foil, and we have another sheet of aluminum foil. These sheets were cut roughly about the same size. Now what we're going to do is we're going to decrease the smoothness of one of the sheets, which means we're going to take one of the pieces of aluminum foil and wrinkle it a bit. So now I'm going to wrinkle the foil. Now that one of our pieces of foil is wrinkled, you can see how this one's a lot more bumpy than this one, right? So now what we're going to do is we're going to turn off the lights, and I'm going to shine a flashlight onto the smooth side, and then we're going to measure how much light has been reflected. Then I'm going to shine the same flashlight onto the bumpy piece of aluminum foil, and then we're going to measure how much light that reflects. As we shine the flashlight onto the smooth aluminum foil, we're going to use our light meter to measure how much light is being reflected. Then, after we document our results, we're going to use the same flashlight to shine on the bumpy aluminum foil, and we're going to collect the data from our light meter as well. Then we're going to document how much light the bumpy aluminum foil reflected. Okay, so now I have the lights off. I just have some ambient light coming in through the windows. But you can see that our light meter is currently reading 0.2. So this is going to be our baseline of the room. So anything brighter than 0.2 will be the light that is being reflected from the aluminum foil. So now my light meter is reading 0.1 FC. The way that I'm going to do this lab in order to measure the reflection is I'm going to have the flashlight pointing away from the light meter, and then I'm going to use the aluminum foil to angle the light so that it's being reflected into the sensor of the light meter. Okay, so now with the light turned on and facing away from the light meter, you can see that my light meter is reading 3.4 FC. So I'm going to use the smooth aluminum foil to angle the light so that it is hitting the sensor. And you notice that the sensor is going up. Right now it's about 248. It's going to move up and down because the light that's being reflected is shaking a bit. Okay, so now I'm shining the light and I'm reflecting it. I don't know if you can see in the camera, but right now, currently, it is 346. And the more you can concentrate that light into the sensor, the higher your light meter will go. So right now it's about 449. Going to see if I can get a good average. It's important that you hold it steady. So it's So the lowest I'm getting right now, it's 329. Okay, so we're gonna go 329, 320, 315. So with the smooth aluminum foil, we were able to get a reading of over 300 FC according to our light meter. Now I'm going to leave the flashlight in the same position, and I'm going to switch out the smooth aluminum foil with the crinkled aluminum foil. And we're going to see those results. So I have my aluminum foil, it's reflecting the light, and you can actually see that some of the light is actually going through the aluminum foil. So it's being transmitted through the aluminum foil. So that means that we're going to lose some of the light as well. So the light is bouncing off of all of the bumpy surfaces, and let's see our reading for our light meter. Currently the light meter is reading 18.7 FC. So if you can notice, before we were over 300 and now we're barely almost at 20. So you can see a huge difference in the crinkled aluminum foil versus the smooth aluminum foil. So for our materials, we had 2 sheets of foil. One was smooth and the other one we made bumpy by crinkling it. We also had a light meter to capture our data and a flashlight. Now our dependent variable, this is going to be the thing that we're measuring, the outcome that we're looking for. So our question, if you remember, it says, how does the smoothness of a material affect the reflection of light? So the thing that we're measuring is how much light is being reflected by each type of foil, either the smooth or the bumpy. The control variable, this is the thing that we kept the same during our science experiment. So what stayed the same in our science experiment? We used the same flashlight. We used the same light meter. And we kept both the light and the light meter in the same position. So our control variable, the things that we kept the same during our experiment, we used the same flashlight and light meter. We also kept the light meter and flashlight in the same position. I was being very careful to keep the foil the same amount of distance away. So the smooth foil and the bumpy foil were an equal distance away from the light meter. The independent variable, this is the thing that we changed during our experiment. Well, if you look back at our materials, we had the smooth foil and we had the bumpy foil. They're both the same type of foil. The only thing that we changed was the smoothness of the material. And if you look, one is very smooth and the other is very bumpy. So what do we change? We changed the smoothness of the material, or the smoothness of the foil. So based upon your observation during the lab, how does the smoothness of the material affect the reflection of light? In the diagrams 1 and 2, I would like you to diagram your observation. In diagram 1, show what happened with the smooth foil, and in diagram 2, show what happened with the bumpy foil. Well guys, thanks for watching. See you next time.